So now in this video we're going to look at a latching relay. So it stays in one of two positions with a pulse. Most other relays, they have a position when it's not energized and then another one when it is energized. You need to keep giving current. But in any case, right now the rear LED is lit up, and before it gets hot I'm going to pluck it. You can see that the relay doesn't need any current at that time. It's a mechanical switch actually, and there's moving parts. So there's a little bit of resistance in everything. So the less we attach to the LED, you know, a little bit more current will go through. But for the most part, it's a mechanical connection, like the jumpers and everything else. And I mostly like turning the power off and stuff so things don't get too hot so I can touch them. But again, we switched that position. Since it's a latching relay, it stayed in position after I removed our signal. And oops, I turned the power off. And there you can see it's the same amount of current there as if I just have this going through the relay right there, other than a little bit of resistance from the switch. So now we'll zoom in to get a better look. One reason why you'll see relays a lot is how much current they can handle. We got about 2 amps of current there, and you could see the difficulties I had switching these with semiconductors and stuff. They just don't handle current as well as the mechanical switch in there. This is actually a low amount of current for a relay. Usually they can go like 20 amps or something, but this latching relay is lower for some reason. One reason why I'm using it, it's a 5-volt relay. I was going to use a 12-volt relay, but these are 5-volt LED modules, so I would have had to modify things. And so I grabbed the 5-volt relay I had. I have relay modules at 5 volts, but I wanted to use the actual component there. So these are kickback diodes right there. We have the current when you can see we got positive power supply is off, but when you apply power, current goes through the coil there. When you remove it, the current doesn't stop instantly, so that just gives it a little path back to the coil so that current flows until its magnetic field collapses, which is pretty close to instantly. This is avoiding a spark somewhere. It's just popping, dropping right down. So we got those 2 pins there. They were going there to those jumpers, and again, coil is going across both directions. Now, this is an interesting relay. Usually the common pin is there. So this pin is either electrically connected to that one, and it's electrically connected to that one, I should say. This one, the common pin's down here, so it's either electrically connected to that one, so that is, you know, the same possible position, or it's connected to this one, which is odd. Usually those two don't connect together, but in this case it does, because that is the common pin. So that was going there, and there could be another pin there that would go there, but there isn't. Then we go up to the middle pin, that goes to that spot right there. And this top pin there, again, there could be another pin there that would be where this jumper is, but it goes to the supply instead. It's just a gap there. And then right above it, right there, is where that pin would be. Hopefully that makes sense. So, as you can see when I plug it into the board, it's hard to tell where those pins are going. But we'll turn the power back on. You can see that LED is on, so we know we wired it properly. That was the upper LED. Now that's the lower LED. We switched which LED was on. So, in any case, when it comes to these higher wattage LEDs, maybe relay is your best option. There's relay modules that say they're latching relays so that they work like this one, but it's a module. You give the module a signal, it switches and holds in one position, but the relay itself probably is not a latching relay. The module is probably just keeping the coil energized while it's in the energized or the not normal position. So you got to be aware of that in case you're worried about the power needs of the relay and whatnot. This one, the relay itself, doesn't really need any power other than right when you're switching it. After that, it'll stay in one or the other state. It doesn't take up any power. It just drops like a little bit of current that goes through the load. Very, very small amount. Because there's a mechanical connection, it has a little resistance. So, in any case, that's it for this video. No diagram. Sorry for those that want a diagram in every video. Didn't make one for this one. So, thanks for watching. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.